Okay. So 3 problems to do. We're going to hit all 3 of those. And I need you to make sure you're double checking what I did. What is that? You are my new neighbor? Oh, okay. I'll get that corrected for you. Uh-oh. Hey! You all right? Good. So, I need to give y'all a heads up. Nothing bad. I wrote each and every one of you a postcard. It took me like 3 days to write them out. But over the next couple days, y'all should be getting a postcard from me in the mail. And it's a good thing. So, gave you a little personal note, little something that I notice about you. So that's there for you. Cool? And again, you didn't do anything wrong to get it. It's let's see, are we all caught up in this class for the most part? Here. All right, what page was that homework on? Thank you. 119 and 120. So make sure you have that out, even if you weren't here yesterday. 119, 120. And it was 468? Is that right? All right, so problem number 4 is 2x squared plus 5x plus 3, and that's equal to 0. And number 6 is x squared plus 6x minus 5. Oh, thank you. That's equal to 0. And then number 8 is
x squared minus 3.
X squared minus 3x?
X, yeah. And then plus 1.
Then plus, what, 1?
1.
Okay. All right, so let's recap real quick. So there's a formula that we use. It's called the quadratic formula. And it derives pretty good. But I want to show you, before we go through this, I want to show you where the quadratic formula comes from. Because any formula in math was derived from something else. But do you remember when we were putting, if we were graphing the parabolas and there was one form called the vertex form? Remember that? And the vertex form was, we had to complete the square of standard form to get to vertex form. Okay? So just so you know, this is what we're going to get to. And the thing unique about this is you do have some definite number values that are constants that always exist. So let me show you how this is derived. So this is solving for an x value. This is solving for what we could plug into our solution, or what we could plug into our problem that would allow us to get 0 for an answer. Okay? So this, that's standard form, right? Agree? All right, so follow me on this, and I'll write down all the steps. First step, divide all by a. Hey, what's 0 divided by a? 0, okay. Next step. Remember Remember that one non-mathematical thing, make a space? Remember that? Is that okay so far? Okay. So I need to focus on this right here. I'm going to have this be our perfect square trinomial. Now it's missing something right now. So remember, this next step, I'm going to multiply two things together. So if I take half of a fraction, do I just double the denominator? So if I wanted half of 3 over 8, is that 3 over 16? If I wanted half of 3 over 4, is that 3 over 8? If I wanted half of a half, that's 1/4, right? Does that make sense? So if I want to do half of a fraction, I'm going to make this b over 2a. Is that okay? So take half of b over a term, square it for space, and be sure to add to both sides of the equal sign. Okay? Nice thing is, if I add to the other side of the equal sign, I'm adding to 0, so it's just whatever that is. All right. So take half of b over 2a. Did it. Square this. So what's b times b? B times b. B squared. What's 2a times 2a? 4a squared. So if I add it here, I have to add it to this side of the equal sign too. Is that okay so far? So now I'm just going to kind of clean this up a little bit. Does that look okay? And I'm not asking you to be able to do this, but I'm just, do you think my math looks okay? Okay, so I added it here and here. 0 plus this is just this. Move c over a to other side. So I have to subtract it. Does that seem okay so far? Get common denominator. The only place I have a denominator over here is just that, so move this over a little bit. What's my common denominator? If I have a 4a squared and an a, what do I have to make this denominator to add to this here? What do you think? 4a. You make them both 4a squared. So I'm going to multiply this by 4a and this by 4a. So then that's going to give me equals b squared over 4a squared minus 4ac over 4a squared. Are those the same denominator now? So let's put the right side just with one fraction. B squared minus 4ac all over 4a squared. Hey, what did I say we were solving for in the very beginning? What do I want by itself? X. Okay. So I have this quantity right here that's squared. I have this quantity that's squared. What undoes the squared quantity? Square root. And what should you not forget? Yep, add and subtract. Good. Okay. So don't forget the add and subtract. So this is now just x plus b over 2a. Hey, wait, where'd the squared go? Well, I took the square root of it. It's gone. Equals plus or minus. I can't take the square root of base squared minus 4ac because it's not a perfect square. But what is the square root of 4a squared? 2a. Get x by itself by subtracting this. Do those appear to have the same denominator? Put them together. I'm not asking you to understand the math, but you have seen to complete the square. And I'd say about half of you would, if with a little guidance, would be able to go back and complete the square on a vertex to find a vertex again. That's all this math is. Is that the quadratic formula? Yeah. It derived from a regular formula. It derived from a standard form to solve for x. So we didn't just make up some formula that just worked. It's derived. And that's the math behind it. And I mean, if you look at this, look at all this writing on this slide. Yeah, it takes a little bit. Okay? Kind of a math geeky thing to do, I get, but. So that's my formula. Remember that formula? We said was that formula, right? You see where the numbers come from? The 4 and the 2 and the squared. They all come from because we derived it. All right, so let's work these problems. Okay? First thing we want to do. A equals what? 2. B equals what? C equals what? So that's the first thing. Is everybody comfortable with how we get the A, B, and C? Hey, can we find the A, B, and C if it's equal to some other value? If it's not equal to 0? No, I want it equal to 0 first, so I have to move things over to make it equal to 0, and then I can find my A, my B, and my C. My A always is attached to the x squared term. If I just have x squared, what's my A value? 1. Okay, if I just have x, what is my B value? 1. And C value should have, if the C value is missing, what should you put in if it's missing? 0. If the x term is missing, what should you put in? 0. If the x squared term is missing, you don't have a quadratic. Quadratic formula doesn't work. All right, so remember, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Were you able to watch the video? I sent your mom the link. Last night, you didn't watch the video? Anytime you miss my class, it is your responsibility to watch it. Okay? This is a big concept. This isn't just like, I can wing it. I don't record my classes for the heck of it. I record for the absent student. Okay? Please be responsible and watch it. Okay. Thank you. Okay, we're going to start plugging things in. What do we need to watch out for when we plug things in? Well, there's negatives there, there's squared terms there, there's numbers there, there's a square root there. We got to make sure those are all there. So the things we're going to plug in for, I'm going to plug in here, 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 and here. The negative outside, that's going to stay there unless it's a negative being plugged in and switches. The plus minus stays there. That squared stays there. This minus 4 times those quantities stay there. That 2 stays there. Okay? All right, x equals negative b. What did I say the b value was? 5. Plus or minus square root. What am I squaring?
5.
Minus 4. What's A?
2.
2. What's C? 3. All divided by 2 times 2. Okay. These get multiplied. Okay. You can't go 5 minus 4 first. You have to take care of the order of operations. Okay. So equals -5 plus or minus 5 squared. 25. Good so far? Okay. -4 times 2. -8. -8 times 3. Careful. -24. All over 4. Agree? Hey, what's 25 minus 24? 1. Oh, that's pretty cool. What's the square root of 1? Where did the square root sign just go? Well, I took the square root of 1 and I got 1. So where did the square root sign? I undid it. How many answers is this going to be? 2. So this is what x is equal to. Okay? So we're going to separate it. We have -5 plus 1 over 4. And I have -5 minus 1 over 4. -5 added to 1. -4. -4 over 4. -1. -5 minus 6. Or I just gave it to you. Minus 6. Reduce that. -3 over 2. That's what my x values are equal to. What do those values find us? If I take any of those values and plug it back into the original problem, I get 0. If it was y equals and we use this to solve it, this tells us exactly where it crosses the x-axis. Okay? So it's a formula to undo things. This is a higher level of thinking. There's a lot of little tiny places to make the mistake in that equation. Be cautious when you're going through it. Don't be, oh, I can do this in my head. I understand there is some arithmetic you can do in your head. I get it. But it's okay if you write down your steps and show things falling out. It shows the thought process. It shows a direct learning of the material. Can I move off this answer? Everyone feel comfortable? All right. Okay, next question. Our very first thing, is it equal to 0? Cool. So my A value is what? 1. My B value is what?
6.
My C value is what?
-5.
Good? Did I just do this one? Oh, okay. Scared me because I just did that one, right? Okay. No, you're okay. I wouldn't put it past me working the same problem over again and having 2 different answers. Go, what the heck's he doing? All right, ready? X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, still the same, right? Places that I will plug things in for that b and that b and that a and that c and that a. But there's signs that and numbers that go along with them, so we got to make sure they're there. All right, so x equals -6 plus or minus the square root of what squared? 6 squared minus 4 times what? Times -5. All over 2 times what? We okay? There's some negatives up there we can't forget. Does this -6 stay -6?
No. Yes.
Yeah, it's not -6, it's just -6. So I have -6 plus or minus 6 squared. 36, I love it. Now be careful. This is where I want you to be careful. -4 times 1. -4. -4 times -5. +20. All over 2. Is that okay how I just did that math? Does everyone see how the sign just changed? Does everyone understand why the sign changed from a -4 to becoming a positive? Because there was another negative in there. So let's do the arithmetic. So the addition. negative 6 plus or minus 56, right? Do I know what the square root of 56 is? No, it's bigger than 7, less than 8. But let's see, can I break 56 down? Does 4 times 14 give me 56? Does that work? 4 is a perfect square, right? So what is that going to change into? Do what? Good. 2 square root 14. All over 2. Okay. Now, anything outside. Let me underline things that are outside the radical. This is outside the radical. This is, and this is. Does that make sense when I say it's outside the radical? What's inside the radical then? 14. So I can reduce anywhere outside to anywhere outside. So 2 goes in itself once, goes in there once, goes in there 3 times. My answer is negative 3 plus or minus square root 14. That's my answer. That's what x is equal to. Agree?
Yeah.
Okay, wait. So how come you didn't just do negative 6 plus 56?
Because I could break root 56 down. I can break it down to a component with a smaller value. So I can break 56 down. Root 56 is equal to root 4 times 14, which is equal to 2 root 14. So it reduces down to a nice exact answer.
Okay, do you have to divide them by the same number? Wait.
Well, yeah, so like I can't divide the first term by 2 and then the second term by 5 or something. So you're usually looking at the denominator. That'll tell you if it reduces or not. Okay? Ready to move to the third one? No? What do you got?
Okay, so for his work, he was asking, look, can you look at his?
Yeah.
Got like a straight number.
This is one.
But
I need to break down the.
So we're good here, right? And then the root 56 is 4 times 14. Square root of 4 is 2, so I get 2 square root of 14. So I put that in for that. Okay? Good? Can I move on? Anyone still need to hold off? Why am I taking my time on this? Because it's like the number one concept of Algebra 1. This is the good stuff. All right. Last problem of the 3 I asked you to do. Is it equal to 0?
Yes.
Okay. Can we identify my A term?
Yeah.
What is that?
1.
What's my B term? What is my C term?
1.
Okay. Right? And we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? We're good with that? Again, that formula hasn't changed, has it? So let's plug in. Plug it in that, for that, for that, for that, and for that, right? Don't forget the things. It has negative signs associated. Good. So x equals negative. What's b? Negative 3. So now we got a negative 3. Agreed? So that's going to have to change, but we're not going to worry about it yet. We'll just keep there. Plus or minus. What am I squaring? Negative 3. Now let me ask you this. Common sense. Come on. If I go negative 3 squared, what do you know the answer has to be? Positive. I know you're going to plug in your calculator, and I promise you, you're going to plug in your calculator, and it messes you up. I mean, watch what happens. Let me pull up my calculator here. I just want, I'm going to pause on this for a second for a reason. Go to my, because y'all want to use the big, cool calculators. Let's pull mine up. So negative 3 squared, right? We know it's 9, right? Is anyone here who's like, I think it's 56? Okay, ready? Watch. You plug this into your calculator. I think that's what most of you are going to want to do. Now, we all know negative 3 times negative 3 is? Positive 9. What's the calculator squaring? The 3. And it brings the 9 along. If you want to plug a negative in and you want to square it, you have to put it in like that in the calculator. That way it knows that you are plugging a negative 3 in. And that gives you the 9. I will tell you, it's unbelievable how many errors take place where it's like, oh, well, it told me that negative 3 squared is negative 9. Be a little smarter in the calculator. The calculator is just doing math iterations where it adds really quickly. That's all it does. That's how the program works. Be smarter than the calculator and be understanding of how the calculator reads things. The calculator reads this as 3 squared. I want the opposite. Calculator reads this saying, hey, I'm going to take negative 3 and multiply it times itself a second time. Okay? And I know that looks goofy, but it's like there are so many people who want to say, well, I'm going to trust my calculator, so it must be right. No, your calculator is a dumb machine. You are a smart human being. You're plugging into a dumb machine. Don't trust the dumb machine. Trust your gut. Your instincts are right. Okay? It's not like some magical anomaly happens overnight where it's like, oh, if we square a negative number, now it's going to be negative still. It's like, oh my gosh, no. Okay, and I'm saying that because I've taught for a long time. I see that error always. And a lot of times it's because people are trying to go a lot quicker through the problem and they're not using this. They're going, oh, just show me what button to push. Really? That's what your job for life is? I just want to push this button every 6 seconds. No, you don't want that job. Yeah, but it pays well. No, you don't want that job. All right, so we're right here. So I have the minus sign. And that 4 comes along, right? What's my A value?
1.
What's my C value?
1.
Okay, good. Is it okay that the A and C value are the same thing?
Yeah.
Sure. All over 2 times. What's my A value?
1.
Good? All right. Common sense time. What's this going to give me?
3.
Positive 3. Why does it do that? Because it's saying, hey, I want the opposite of the opposite of 3. Huh? I want the opposite of the opposite of 3. What's the opposite of 3? Negative 3. I want the opposite of that. Positive 3. Plus or minus? What do we got here? 9. Minus 4 times 1 times 1.
4.
So I got minus 4, right? All over
2x.
2.
Oh, 2, yeah.
X equals 3 plus or minus square root 5 all over 2. There's my answer. That's it. It's done. Do I need to go much further? It's done. So is that done like that? Yes. Okay. I want you to take the rest of the period and I want you to complete.
I have a question.
Yeah.
How come you didn't do 3 plus 5 and 3 minus 5?
Plus or minus. It's already in there. Shortcut. So this plus or minus right here. Because I can't go 3 plus 5 and get a number that I would know. It doesn't come out to like 7 or something. If I had 3 plus or minus square or 5 itself, do I have square root 5?
So, if it's square root, then you don't do that?
It won't add. You just leave it. So your answer to this problem, longhand, is this. Those are your 2 answers, but we shorthand version it, putting it like that. Do you see how these are a little different?
Yeah.
So the plus minus takes care of it. Okay? So, between now and Monday would be the next time we'd have class. I would like you to have page 119 and 120 done. So Page 119 and 120. Done. You can handle it. When it says factor each quadratic equation, use the zero product property to solve. If it says to factor it, it might factor. If you can't figure out how to factor it, then use the quadratic formula on it, because guess what works? And you guys have plenty of time to get a good start. Looks like you got about 14 minutes left, right? So let's get working on it, see how you do. Good?